This evening I'm going to have a look at this scope I picked up yesterday afternoon. Trawling through eBay, just having a look to see what was available, see if there are any sort of bargains or anything worth having. Wasn't really looking for a scope, as you know. I've just got the Iwatsu, and that's works pretty well, but it's not perfect. There are a couple of problems with it. One of the biggest problems is the triggering is pretty awful, and it's very prone to not triggering easily, and not fiddly to use. I've had a lot of experience with those particular scopes, so it's not a problem really with using it. But the triggering was always flaky, would never trigger on anything particularly complicated other than sort of like a sine wave or square wave. So I was sort of looking through and see what was available, and I came across this scope, this Tektronix 2440. It was sort of ending within the hour, and I was sort of had a quick look over it. And it was a very low starting bid, or certainly for the specification of scope. So I made the first bid on it and thought, well, I'll probably get outbid because it's quite a high spec scope. And actually ended up winning it. So I picked it up yesterday afternoon. I went to the seller who was selling it. Used to work at Fujitsu, computer company, and has sort of since retired. But before that, he was repairing TVs off his own back, and he used to use this scope for repairing his TVs. He said, but he doesn't use it anymore, and he had an older Tektronix there. So I powered it up there, and it all appeared to be working absolutely fine. It came up with a checksum that was good, and all the self-diagnostic screen was all passes. So I thought that looked fine, and he seemed to be a reasonably genuine sort of person. I mean, you can't really tell. So I bought it back, and initially I powered it up last night, and I thought I was recording it on video, but I wasn't. The battery died in the camera. But what actually happened was, when I powered it up last night, it came up loads of fails when I got it back home, which is pretty typical, isn't it, when it sort of works fine at the customer's or the person who's selling its house, and then fails when it gets here. Anyway, I sort of messed around with it and couldn't get it to couldn't work out what to do. So I left it last night, and I had a look at it again this morning after reading the manual. And there's a calibration process you're supposed to run, and if you don't run the calibration process and then it can finish, it will never let you start the scope up until it's completed this calibration process. So anyway, long story short, I finished the calibration process and it worked fine, and that's what the stage we're at now. Now it's in lovely condition. It's obviously been very well looked after, and it's also come with all its books, which is nice. It's got all the manuals for the HP, the Tektronix scope. This is the operator's manual. We've got a GPIB interface book about how to use all the commands. There's a quick reference guide here. We've also got the programmer's guide for entering all the GPIB commands, and also got a bag of leads, which is nice, a bag of scope probes, and these are the Hewlett-Packard scope probes. I don't know why. Obviously we're supposed to have had Tektronix, maybe the Tektronix scope probes, he used them on another machine or something. But they're nice. They're the small sort of delicate type ones, the sort of low profile type, and they've got all the adjustments and the BNC adapters in there. And you can see the little identification rings on there, trimmer tools, clips, all sorts of things. So that's all nice. It's got a few other bits and pieces. It's got a spare protective screen for the display, which is also, I don't know if that came with it as original, but and a couple of these little earth clip things. These earth clips are used for if you're working with very high frequency. It cuts down the sort of coupling noise from the earth lead and things. If you're using, rather than using the earth clip to the chassis, you connect this to a local earth point, and then you've got a clean sort of signal getting to the scope probe. And it's quite an elaborate scope actually. It's a 300 megahertz, which is one of the reasons why I wouldn't have bid on it if it was just another 100 megahertz scope. circa 19, I think about 88. I think this came out, this scope, 88, 90, something like that. It's so it's coming on 25 years old. GPR, as you see, it's got GPRB interface bus, but it's got lots of it. It's got the cursor read measurements, which is nice, but it's also keeps a lot of the measurements up on the screen, so you can actually sort of show information on peak to peak, frequency, duty cycle, all sorts of other measurements. Now it's quite a sort of, it's going to be a bit of a learning curve to get how to use this thing, because I'm used to working with Hewlett-Packard scopes at work, and I always find them much more intuitive. But I thought we'll power this up and have a look, and I'll give you a quick run through of what it does. Let's power it up. Now it has got a fan inside, and it's a large diameter fan, so it's not the sort of like, it's quieter than the, though it might sound quite noisy here, it's quieter than the Iwatsu. So let's just get this powered up. Just move this into position where you don't get any glare off the... Now that's one thing it does do that's a little bit strange. After initial power up, it does this sort of like, it shows a display like it's oscillating, but then it shuts down straight away once it's been on for a while. So this is the display is up and running. The CRT looks fairly bright, but it's a bit difficult to get it really sharp. I've adjusted the focus and things like that and the astigmatism, but it's sort of a bit sort of soft, maybe the image, maybe the tube's a bit weak. But let me just quickly go through and show you what it can do. I'll connect it up to my function generator. So there we go, we've got a frequency there of should be around 15.5 kilohertz. Now this frequency here is the readout of the measurement with cursors. This is the cursor control here. And you've got various functions. You can have volts time, volt, I don't know what that is, volts at T, I don't know what that is, voltage at time maybe, so you can scroll along, it will tell you the voltage on the rising and falling edge of the sine wave, slope, and a time /1, I think that's actually kilohertz as opposed to one's in milliseconds and one's in frequency sort of thing. It's also got other measurements, and it's got an auto measurement thing here. This is the auto calibration mode where it will sort of set its best range, and it's actually quite slow at doing that, but it actually is quite useful if you've got a complicated display on the screen and you can't be bothered to fiddle about with it. Just press the auto button and it should lock in. We've got a measure button here, and that measure button, if I turn the display on, it gives me these frequencies here. Now I can adjust these intensities independently, so I can have the CRT, the waveform turned down, or I can have the display turned up, so I can do everything independently from this one control. This control controls all the intensity for the graticule. I'm not sure what intensity does, because that doesn't seem to affect anything. The display is the waveform, the readout is obviously the readout, but that one doesn't seem to do anything. But that's a nice addition, because you've got that constant readout all the time, so you can have that on in the background, and that makes it a lot quicker for sampling you know, voltages and frequencies, and just if you're going through and just wanting to know what the voltage is on the scopes without messing about trying to work out what range you're on and things, that's great. The Iwatsu does that, but it doesn't, you can't have it come on as a default, whereas you can, by the looks of it, on this machine. What else have we got? So it's quite an unusual adjustment for these controls. Now we've got these pots here are, you see there's a small turn, that's the limit of travel of the normal pot. You can see that's full travel, but beyond there it's spring loaded, and it's velocity sensitive as well, so it allows you to set roughly the right position, and you've got that fine control there. But if you need to go further, you have to push it past the spring position. And that's nice, I like that system. It will get a bit of getting used to, but it's certainly unusual. I've never come across that before. We've got variable calibration for an attenuator, like you'd expect on all scopes. You can invert the waveform, and you can ground the output. You can select a 50 ohm terminator, which is quite unusual on the scope of this age. I haven't come across that before. We've got the bandwidth limitation for 20 megahertz, 100 megs, or its full 250 megs. That smoothing gets rid of this sort of jittering on the scope. I don't know if you can see that on the display. It's sort of like almost like noise. You put smoothing on, it cleans that up. That's nice. Now we've got another thing here for delay events. I don't exactly know what this is, but I think this is all down to the it's got a delayed trigger, and as a lot of the Tektronix scopes, so that you can delay the trigger. That will be I will never use that, or I doubt I'll ever use that. But you can adjust the delay of the time base B. There's two time bases, time base A and time base B. I think time base B is the one that's variable, or adjustable for delay, should I say. Then you've got the storage mode here. That's your acquisition mode, where it's constantly updating. Save is basically you can save the acquisition to a file, by the looks of it, to a reference file. And then you can also display that reference file by pressing this button. I think I'm having a bit of a guess here because I haven't actually used these scopes, and it will display it as an overlay. And then we've got our triggering system here, a pretty standard triggering, level control here, hold off for your trigger, so it delays the triggering mechanism by a number of microseconds usually, and it's shown here as a hold off. Got A and B triggering, and different modes of triggering: normal, envelope, for average. Oh, sorry, no, that's for the acquisition mode. So that is, yeah, A or B triggering. I think that's if you select the different, if you're triggering off the different time bases. And we've got slope. Let's get rid of that. Slope. Where are we? So that's basically this triggering on the positive and negative going slope, as you can see on this LED here. This thing here is must be coupling. So different coupling modes: DC coupled, which is what you usually have on, AC coupled, and noise reject, high frequency reject, low frequency reject. So we have that on DC. Trigger position. I think basically what that does is trigger it where it positions on the screen. And it's the options are an eighth, quarter, half, 3/4, 7/8. So I imagine that's triggering up parts of the screen. Actually, can we see that? Should see that T move if we do that. It's not moving. Ah, there you go. Half. You see the trigger's moved to this point. Press it again. It's right over here. Try again, and it stays there. So it does look like it's where it's triggering on the screen. And you've got the initial set the instrument to 50% trigger, which is a standard thing that Tektronix seem to use. And you've got a load of other options here, different triggering modes, delayed trigger starts and things like that. You've got this set word thing here. I'm not sure how that is, but I think it's to do with triggering off a some sort of logic. And you can see here it's got different options for looks like logic triggering. That looks like to me the triggering on positive going slope or negative going slope. But I doubt if ever that I'm ever going to use anything like that. And of course you've got the normal position control here. So that's, you know, that's pretty standard for all scopes of this sort of age. What else have we got? And we got setups. We can save setups as you can on most scopes. You know, you can have a particular setup where you want to recall a set some parameters like DC. I want DC coupled at 2 volts, 200 millisecond time base, rather than have to do that each time for a particular project or something. You just store it in memory and you can recall that, and it will be straight away set up on the screen. You've got your external calibrator. And you've also got, an internal calibrator, and you've got 2 external trigger points. And you've also got a load of ports on the back as well for a video out, which is quite nice. So you could actually, in theory, put all this onto a screen to see it. But it all seems to be working fine. It's got various diagnostic programs you can call up here. And this is basically, press this button, it gives you a rundown of what's what the system's set to at the moment and what's in the memories and things like that, and you can see that all looks okay. I don't know what this external function is. I've only really scratched the top of the surface of this scope really. It certainly seems to be quite a lot of features on it, so it should be more useful than the Tektronix, and it's just going to be a case of getting used to it and trying to I think it will be better. I think it'll be an easier scope to use than the Iwatsu once I've got it all set up. I'll also be interested to see what the picture quality comes out like on this video. I'm using a different camera this evening. I left my other camera at home, and this is a Lumix LX5 from Panasonic. I've had this for quite a while. I never used a video on it. It's only 720p I think, but hopefully the image quality should be good. It looks good in the viewfinder, but I won't really know until we play it back on YouTube and see what YouTube do to it. But anyway, yeah, thanks for watching, and maybe once I've got the scope up and running you'll see it in action.